Hi everyone, welcome to Vedantu NEET English. I'm Diksha Kaushal, your chemistry master teacher. How are you all, everyone, in the chat box? Yes, everyone in the chat box. Am I visible? Am I audible to all of you? Okay, so today we are going to do most predicted, most repeated PYQs from your CBSE syllabus, right? This is going to be a very important lecture for both NEET aspirants and for CBSE aspirants. This is like a gold for you, right? So guys, I am going to start the lecture. Everybody please join in so that we can start the lecture without wasting any time. I am going to do the PYQs from whole chemistry, whole complete class 12 chemistry. So everybody join in so that we can start the session, that is class 12 chemistry PYQs. Shall we start, everyone? Shall we start? Okay. Shall we start, everyone, in the chat box? Yes. Very good evening, bacha. Very good evening. Very good evening. Very good evening. So let us start the lecture. Let us start the lecture. Everyone in the chat box. Yes. Where is your Josh? Where is your Josh? Where is your Josh? Huh? Where is your Josh? Are you feeling tensed? Are you feeling nervous for exam? I am, taking care of everything here. Like we have done the class 12 complete chemistry marathon. We have concluded all the chapters, important point of all the chapters. Now we are going to do PYQs of your most repeated, most expected questions for your board examination. Okay guys, so let us start the lecture. The very first question here, value of Henry's constant. Firstly, tell me the value of Henry's constant. It increases with decrease in temperature, decreases with increase in temperature, increases with increase in temperature. So Henry constant for a particular gas, it increases with increase in temperature. So the answer is C is going to be the correct answer here. It increases with increase in the temperature. This is your 2023 question. Next part here is that in a 2023 question, that is assertion. Always how to do assertion based question. See this very carefully. Now the assertion is like, this is a question, okay? So firstly you have to write whether the two statements are correct or the two statements are not correct, okay? So first is here, osmotic pressure is colligative property. Is it true or false? Yes, it is true. So I'll write true here. Osmotic pressure is proportional to molality. Osmotic pressure is not proportional to molality. It is proportional to molarity. So this is a false statement. I will write A is true and R is false here. That is C is the correct answer here. Yes, everybody, very good. Next question here. This is the numerical. For numerical, everybody see this very carefully. Now you have, everyone here, now you have this question. From this question, you can see when you have 19.5 of this much. Now, what is this 19.5? Everyone, what is this 19.5? This is your solute. And always I am going to represent 2 for solute and 1 for solvent. And 1 for solvent, okay? 2 for solute and 1 for solvent here. So everyone here, see this very carefully. Now you have, this is W2, that is weight of solute, right? This is the molar mass of solute, that means this is M2 here. Then it is dissolved in this much of water, that means this is W1, okay? This is the weight of solvent here, right? Okay, the depression in freezing point, that is delta TF is this much. Calculate the degree of dissociation, that means first you have to calculate the Van Hoff factor here, okay? So what is the formula? The formula, bacha, here is, the formula is delta TF is equals to I KF into molarity. And if we talk about molarity, that is weight of number of moles of solute, that is weight of solute by molar mass of solute into weight of solvent. If this is in grams, this will be multiplied by 1000. And in this formula, you have values of delta TF, W2, M2, W1. Kf is also given to you. Here you need to calculate the I value and then put the value in this one. That is I is equals to 1 plus n minus 1 alpha. Here we are going to calculate the value of where n will be where. What is the value of n? Now this is the value of n. You have F, CH2, COO negative and H positive. So the value of n is going to be 2 here. Okay, the value of n is going to be 2 here. So I am going to write it here. That is n is equals to 2. Right, where n is equals to 2. So here, after putting the value of n, I will get the degree of dissociation and this is your particular answer. Right, this is how you will get your answer here. You can see this, okay. Here you will find firstly want of factor, then here you will put the want of factor here. For example, here I have, here want of factor turns out to be 1.0075. So I'll put that in. I is equals to 1 plus 1 n minus 1 into alpha. That is going to be alpha is equals to I minus 1 n minus 1. N is equals to 2 minus 1. I is equals to 1.075 minus 1. So here you will have the value of alpha. Right? Okay everyone? Yes bacha? Okay, I'll repeat it for you. So firstly, we saw this statement. Here in statement, we have this much of solute. This is the value of solute. The mass which is lower in value is solute. Okay. The mass which is higher in value is the solvent. Okay. Otherwise, you can see this through the statement that this is dissolved in this much of water. That means this is the solute, this is solvent. Solute is denoted by 2 and solvent is denoted by 1. Right, we just need to put our formula where we are given delta TF, that is 1 degree. We know that the value of KF here, that is value of K is also given to you. Right, for molality, that is equals to W2 by M2 into W1. W1 is given to you, that is the mass of water. This is the mass of solute. This is the molar mass of solute. Everything is given to you. Firstly, we will calculate the value of want of factor, that is I. Now, in this equation, just this is the thing that is not given to us, right? So we will calculate the value of want of factor. Here we will put the value of want of factor and value of n here and we will get the value of alpha, that is degree of dissociation. Yes everyone? Okay. Yes, if you're doing the PYQs and if you've done the marathon that I have done yesterday and if you're doing the PYQs, that is enough for you. Yeah, especially for physical and inorganic chemistry. Okay, for organic chemistry, go through the naming reaction and distinguish test also. Right? Okay, perfect. Now, next question here is, what type of deviation from Raoult's law is observed when we mix CHCl3 and we mix acetone, right? So, when we mix acetone and CHCl3, what is going to happen? There will be H bonding here. There will be hydrogen bonding, right? Because of H bonding, the interactions will be stronger. That means AB interaction is going to be stronger as compared to AA and BB interactions. Because of that, there will be negative deviation, right? For negative deviation, everyone, if we have negative deviation, there must be a written, right? That is, it will give rise to negative deviation here. Wait, this is the negative deviation here, right? Because of negative deviation, delta H mixing and delta V mixing is going to be less than 0, right? And the total pressure is going to be less than pressure of A plus pressure of B, right? This is the negative deviation here, right? Okay, now coming to the next question here, let us see why there is decrease in vapor pressure. We have done that, right? Okay, now next question here, everybody, you need to also practice the question with me. Okay, try to revise the formulas in your mind. Right now you have for a 5% solution, you have a 5% solution. Okay, now we know 5% solution. Okay, now You are given the molar mass. You are given the molar mass. Okay. Calculate the osmotic pressure. Now, what is the formula for osmotic pressure? That is pi is equals to CRT. Now, this C is the molarity here. Right? You are given the value of R here. You are given the value of T here. Now, let us calculate what will be the value of molarity here. Now, what is molarity, everyone? That is number of moles of solute divided by volume of solution in liters. Right? So, that will be W2 by M2, that is number of moles of solute divided by volume of solutions in liters. Right? If I am taking the volume of solution in milliliters, in that will be in milliliters, that will be multiplied by 1000 into R into T. That is going to be your osmotic pressure. Now the question here arises, ma'am, how will we calculate? We are not given W2. We are not given W2. We are not given any volume in the statement. How will we calculate the volume and the weight of solute here? For that, you need to decode this thing. Okay, you need to decode this percent here. Right? This means they have provided you 5% solution. That solution must be for 5% solution. That solution is for, that is weight by volume. It means they have given you, this means they have given you, bacha, this means they have given you weight of solute to be 5 gram, which is dissolved in 100 milliliters of solution. So here I will write weight of solute is equals to 5 gram, which is dissolved in 100 milliliter of solution. Here you get the value of V also and W2 also. Right? M2 is given to be 60 gram. Okay? M2 is given to be 60 gram per mole here. 60 gram per mole here. 60 gram per mole here. What else do we need? Yes, we have the value of M2 also. We have the value of R also and T also. Here we can easily calculate the value of osmotic pressure. Is this clear to everyone? Is this clear to everyone? Bacha, R is gas constant. Okay, R is the gas constant, universal gas constant. Okay, the value that we would put in this equation, that will be 0.0. It depends on the units. Okay, here we are taking liter per liter atmospheric per Kelvin. That will be 0.0821. Right? Okay, that is universal gas constant. Right? Okay, understood this, everyone? How we are going to calculate these? Yes, bacha. Okay, shall we move ahead? Yes, understood this, everybody in the chat box. Okay, tell me in the chat box, is this fine with everyone? Okay, yes, okay. Now let us calculate the next question, that is calculate the mass of ascorbic acid. That means they are asking you the molar mass. Okay, they are asking, they are asking you the W2, that is the mass of solute here. They have given you M2 here, that is molar mass of the solute is given to you. To be dissolved in acetic acid. This is your solvent, okay? This is your solvent. This is your solvent. Where the thing that is being dissolved is called solute. The thing that is where the solute is dissolved is called solvent. Okay, so this is the solvent and this is the mass of solvent, means this is W1. Right? So now they are saying the lowering in vapor in freezing point is this much. That means delta TF is given to you. Now just apply this formula. Very easy. Delta TF equals to molarity into KF. Right? Molarity, KF into molarity. Now what is molarity? Molarity is nothing but weight W2 by M2 into W1 in 2000. Okay, this is your formula for molarity. Now you just need to put the values here. You know the value of KF here, that is given to you. You know the value of delta TF, that is given to you. You know the value of M2, that is given to you. W1 is also given to you. You just need to calculate the value of W2 here. Here we have only one unknown quantity, that is W2. Just put the values here and you will have the value of W2, that is the mass of ascorbic acid. Okay guys, understood this? Yes. Okay, just put the values here, same values, right? Mass of ascorbic acid will turn out to be 5.08. Now this is my tip to everyone here, Now you have just 1 day left for your exam. You don't have time to calculate, do the calculation and all. That is why I am not doing that for you, right? Because we don't have time to do the calculation and all stuff. That you will do in the exam, right? If you are in like good state of mind, if you have good mental state, you have good peace of mind there. So just relax and do not get panic. Even if you are doing the calculation again and again in the exam hall, you are in the panic state, you will surely do the mistake there. Right? That is why I'm asking you, do not do the calculation, just focus on the concept this time. Okay, what is the concept that is being applied in this question? Calculation, you can do the multiplication, plus minus, everything. Okay, yes. Now next question is from chemical kinetics. Now these are the questions that can be asked from solution chapters, right? Now next are the questions from chemical kinetics. First question is, for the reaction 3A 2B, the rate of reaction. Okay, this we did yesterday also. Now see how to calculate the rate of reaction here. Everybody see this very carefully. You have rate of reaction. For rate of reaction, always divide this by number of moles here. Now what is the rate of appearance? What is getting disappeared here? A is getting disappeared, that will be dA by dt. This is getting disappeared, that is why I have put minus here. Now the number of moles are 1 by 3. Equals to what is getting appeared here, that is dB by dt, and here that is getting appeared, and number of moles are 1 by 2. Okay, divide this by the number of moles when we are calculating the rate of reaction. When we are calculating appearance or disappearance, in that case you need not multiply this by or divide this by number of moles, right? Here just put the values here. What is the value of dB by dt? That would be dB by dt will come out to be minus 2 by 3 dA by dt. That is, B is going to be the right answer here. Yes everyone, very good. B is going to be the right answer here. Next you have 23 question. Okay, last year question. Now the conversion of molecule. Now I want everyone to answer this. Very good, very good. Yes, the conversion of molecule A to B followed second order kinetics. Okay, the conversion of molecule A to B followed second order kinetics. Perfect. If the concentration of A, everyone see this carefully, this follows second order kinetics. That means rate is equals to K A raised to power 2. Right? Now if the concentration of this is increased to 3 times, now the new rate will be K into 3 times A. Now because new concentration is 3 times A, right? So I have written the new concentration here. Here the new rate will be 9K A square, right? That means new rate will be 9 of original rate time. Okay, new rate is going to be 9 times more, 9 times than original rate, right? So how it will affect the rate of formation of P? Okay, that means what will be the rate of reaction? Rate of reaction is going to increase 9 times here. Rate of reaction is going to increase 9 times here. Yes everyone, perfect, perfect. The values of calculate, will they provide marks if we found of the values and calculate? So how CBSE gives you exam is that if you have put in the if you have given the right formula, if you have put the right formula there, right, and you have put the values in right manner. Now if there is some calculation mistake, they are surely going to cut your marks, just 1 or 2 marks there, just 1 marks, maybe half marks, depending on the how many marks does that question have, right? But they will surely give you marks for the formula and everything. Okay, that is why I'm saying do not focus that much on the calculation for CBSE board. In NEET examination, what happens if the answer is incorrect, then your whole thing is incorrect. Okay, you will not be given with single mark there. But in subjective paper, if the formula is right, if you know how to put the formula, if know what are the values, if there is some calculation mistake, they will understand. Okay, there is some calculation mistake. Try to make it right. But if by chance there is mistake, even then you will get your marks. They will cut just half or 1 marks. Okay, yes, that is why I am saying for CBSE exam, focus on the concepts here, right? Okay, now second is what is pseudo first order reaction with an example. So now what is pseudo first order reaction? A reaction that appears to be higher order but actually follows first order kinetics, that is hydrolysis of an ester. That is a pseudo first order reaction here, right? Next question, 2022. Okay, 2022 question now you have. See this. Now, how is the rate affected on increasing the concentration of Y 3 times? Okay, so now firstly they have done a reaction if the first order in X and second order in this. Okay, that means they have given, we have a reaction, in X it is first order and in Y it is second order reaction. Okay, that means they are giving you this equation. Now, how is the rate affected on increasing the concentration 3 times? Okay, if you have increased the concentration of Y 3 times, Y you have increased the concentration 3 times. In that case, this is X, this is 3Y and this is going to be square here and this is going to be 9 original rate. Okay, 9 times the original rate. It is going to increase 9 times the original rate. Right? Now, second question here is, if, how is the rate affects if the concentration of both X and Y are double? If both X and Y are double here, this is your new rate, right? This is your K and here X is doubled and also Y is doubled here. So that will be 2 into 4. Okay, 2 into 2 square is 4. 4 into 2 is 8. That is 8 into original rate. Okay, that means here that is increased by 8 times. Okay, it increased by 8 times. Yes, okay everyone, 9 times, 8 times. Just put the values here, right? Okay, very simple question. 2022 question, see. Next is CBSE 2022 question again. Now, the first order reduction. This is not reduction, this is a reaction. Okay, this is a reaction. First order reaction takes 30 minutes for 75 decomposition. Now, how you are going to? You are not going to take X, Y and all that. Okay, very simple method I am going to tell you. Firstly, for first order reaction, what is the rate of the reaction? The rate of the reaction is K, the rate constant is equals to 2.303 T log base 10. This is the initial concentration, this is the final concentration. Now, I am going to, when you have a percentage decomposition, when they will provide you percentage decomposition, how you are going to solve the question, see this. Okay, what I am going to take, I am going to take the original concentration. I am going to take the initial concentration as 100 and now, as I know, 75% of it is decomposed. So, how much will be left behind? How much will be left behind? 25 will be left behind. Okay, because 75% is consumed. If they say 60% is consumed, I will say 60% is decomposed. That means 40% is left behind. And here I have 25% that is left behind. So I'll just write it here. This is 100 and this is 25. Okay, this is 100, this is 25. Now, let us put the values here. What is the value of T here? Okay, T is given to be 30, right? You can do it in, if you want to calculate it in seconds, convert this 30 into seconds. If you want to calculate T half in minutes, just put the value as it is, right? Okay, that will be this much by 30 log base 10. This will be log 4. Okay, log 4 is nothing but log 4 you will say log 4 is nothing, that is 2 raised to power 2, and here applying the formula, that will be 2 will be here, like that will be log base 10 2, right? Okay, we know the value of log 2 here, that is 0.3. Okay, understood this? Yes, they have also given in the value of log 4 here, right? So just calculate the value of K here. You will after calculating the value of K here, put the value of K. Okay, they have asked you the value of T half here. For first order reaction, T half is equals to 0.693 divided by K. After calculating the value of K from this side, just put the value of K into this one and you will have the value of this in minutes. Okay, you will have your value of T half in minutes. Now let us see the formula here. K, that will be 0.0446 per minute, and after that applying the formula you will have T half to be 15 minutes. Okay, you can do the calculation yourself. Yes everyone, perfect. Now next, is there any problem in this? is this is hardly maybe till 6 maybe. Okay, it's a very short session, not a very long session. Okay, understood? Yes. So now this is CBSE 2020 question. Now CBSE 2020 question, bacha, this is A plus 3B give rise to 2C here. The rate of formation of C is this much. Okay, so now let us see how to calculate. Okay. Okay, bacha, ma'am, when will you send the PYQs PDF? Just after this, okay? Just after this, I'll send you the PDF, okay? Just after I complete the session, I'll send you the PDF. Okay, I have one more surprise for you. I have specially made one question paper for the CBSE students here. I will send you the question paper along with the answers. First, you will try the question paper yourself and then solve, then see how many you will be able to just see how much marks you got from that. Okay, understood? I'll give you the link of that question paper. That is free, right? Okay, so now you have the rate of formation as this much, and now let us see this. Okay, now let us see this. This is the rate of reaction is going to be rate of disappearance of A equals to minus 1 by 3 rate of disappearance of B equals to plus 1 by 2 rate of disappearance of C. Rate of appearance of C. Okay, just you should know this equation. If you know this equation, just put the value of this. What is this? This is given to be dC by dt. Okay, this is dC by dt. Just put the value of dC by dt. You will be able to calculate rate of reaction. You will be able to calculate rate of disappearance. Rate of disappearance will be equals to minus dB by dt will be equals to 3 by 2 dC by dt. dC by dt value is this one, and rate of reaction will be equals to half of this value. Right? Okay? Yes, bacha? Perfect. Perfect. Now, next question is, now I just need to put the values here and you will have your answer. Right? Next question, very important question. Very important question. Okay? Usually students get scared of these kind of questions and just skip this question. But this is a very, very simple question. Okay? I'll tell you how to solve these kind of questions. Okay? I'll tell you how to solve these kind of questions. See this very carefully. Now, you have this one. Experiment this. Okay, now they have asked you to identify the rate, the order of that reaction and write the equation. Very simple. Okay, very simple. See this. Now firstly, what I will write here, for example, I will make one concentration constant here. One concentration will be constant here. Okay, so I will make this A concentration constant. So A is constant. When I say A is constant here, that time B is 0.1 and this is 0.4. That means it is multiplied by 4 times. If B concentration is increasing 4 times, in that case, A concentration, the rate is also increasing 4 times. If concentration of B is increasing 4 times, rate is increasing 4 times, that means rate is equals to concentration of B, and this is going to be a first order reaction with respect to B, right? With respect to B, this is going to be a first order reaction. Now, let us see with respect to A how it will be. Now, let us make the concentration of B constant, okay? How we will make the concentration of B constant? This is the concentration of B is constant here, right? Concentration of B is constant here, right? Okay, now let us see here. A is increasing 2 times. A is increasing 2 times, and with that, rate is increasing 4 times. That means when the concentration of B is constant, rate is increasing 4 times when the concentration is increasing 2 times. That means with respect to A, it is going to be a second order reaction. Okay, with respect to A, it is going to be a second order reaction. Can you see this? With respect to A, it is going to be a second order reaction. Now everyone, is this clear to you? How this is first order, how this is with respect to A, this is second order. With respect to B, it is the first order reaction. Everyone here understood this? Yes, bacha. So with respect to A, this is a first order reaction. A, it is a second order reaction. B, it is a first order reaction. Total, it is a third order reaction. The overall rate law will be written like this. And how to calculate the rate constant here? Just put the values here. Okay, just take any set here and put the value. Okay, the rate. Okay, I'm taking this one. I'm taking the third one. You can take anything here. You can take the second one here. That will be much easier for you, right? Just take the second one here and put the values here and put the values here. So that will be, so that is going to be, this will be rate. So here the rate is 6.0 into 10 raised to power minus 3 equals to rate constant, concentration of A square concentration of B. So here just calculate the value of rate constant here. Yes, everyone, clear to everyone? Yes, perfect. So now let us see. So this is all the part that I have mentioned you. They have written it in theory. Okay? Yes? Okay? Yes. Now, next question here is from electrochemistry. Okay, let us jump to the electrochemistry part here. How they are going to ask you questions in electrochemistry. So the first is, which of the following solution of KCl will have the highest value of molar conductivity? Which is going to be have the highest value of molar conductivity? So bacha, molar conductivity, always remember this, they are asking you molar conductivity, not conductivity. Right, molar conductivity they are asking you. So molar conductivity is equals to 1000 into kappa divided by molarity. So that means we can say molar conductivity is inversely proportional to molarity here, and here we will write that lesser, we are going to calculate highest, that means lesser is the value of molarity, more will be the molar conductivity. Okay, so here this is going to have the maximum value of molar conductivity. Very good. Yes, very good. Next we have assertion reasoning question. So now this assertion reasoning question states that conductivity decreases with decrease in concentration of electrolyte. Right, the conductivity is going to decrease with the decrease in concentration of electrolyte. This is the assertion. The reason here is number of ions per unit volume that carry the current in the solution decreases. Let us see which statement is true and which is false. Right, the conductivity decreases with decrease in concentration. That means on dilution, but always remember, on dilution conductivity increases, but on dilution conductance increases, molar conductivity increases, equivalent conductivity increases, but conductivity kappa decreases. Okay, on dilution kappa decreases. This is true statement. On dilution only conductivity decreases, everything else increases. Right? Okay, next part is number of ions per unit volume that carry the current in the solution decreases on solution. What does this mean? Everyone, what does this mean? Now, yes, A is the correct answer. Now write Y here. Number of ions per unit volume that carry the current, this decreases. This is also true. Now, why conductivity decreases? Because conductivity is the conductance per unit volume. So, per unit volume, the number of ions decreases here. That is the reason conductivity decreases. So, this Y is giving us the answer for this. So, we will say A is the correct answer here. Okay, A is going to be the correct answer here. Next is 2023 question. Conductivity of 2 into 10 raised to power minus 3. Conductivity of 2 into 10 raised to power minus 3. Methanoic acid is 8 into 10 raised to power 10 raised to power minus 5 centimeter. Okay. Now, see this bacha. Now conductivity of this molar. This means they have given you molarity here. Is this much. This is the kappa here. This is the kappa conductivity. There should be Simon here. Right? Calculate its molar conductivity. That means they are asking you molar conductivity. Molar conductivity is equals to kappa into 1000 by molarity. So you have molarity, you have the value of kappa. You can simply calculate this. Now always remember to apply this formula. if you want to apply this formula, the kappa should be in Simon per centimeter, not in Simon per meter. The kappa is in Simon per centimeter. That means we can apply this formula here. Okay, now calculate its molar conductivity. We can calculate that. How to calculate the degree of dissociation? This is the limiting molar conductivity. Degree of dissociation is equals to this one and divided by limiting molar conductivity. That means molar conductivity at concentration C, that we will from this equation, that we will take out from this equation, divided by molar conductivity at infinite dilution. Okay, this is going to be the alpha, right? Next thing that we have, calculate the delta G naught at log Kc for the given reaction. Now you need to calculate delta G naught and log Kc for this reaction. Okay, perfect. For this reaction, let us see, bacha. For this reaction, everyone here. For this reaction, I would advise you that follow what I am saying, okay? Because these kind of questions are asked from electrochemistry. So now let us see how we are going to calculate this, right? Okay, everyone? Yes. Now, this is the equation that is given to you, right? So this is Ni, this one. Now let us see at anode what happens and at cathode what is happening, right? At anode you have loss of electrons, right? So this has loss of electrons, so that will be nickel is getting converted to Ni2 positive by losing 2 electrons. At cathode there is gain of electron, so Ag is gaining electron and getting converted to Ag, but there is 2 electron loss, so there should be number of electrons gained should be 2 also. So multiply this by 2, you will have this equation here. This is going to be your anode and this is going to be your cathode. Now let us see this. This is anode and this is cathode. Now next thing here is, now apply the formula here, that is Nernst equation here. Okay, apply the Nernst equation. What they have asked you, delta this and this. Okay, they have not asked you Nernst equation. Okay, they have not asked this one, right? They have asked delta G naught. Delta G naught is equals to minus NF E naught cell, right? N is equals to, here we will see N is equals to number of electron gain or loss, that is equals to 2. N value is 2. Now ma'am, how to calculate the value of E naught cell? How to calculate the value of E naught cell? E naught cell is equals to E naught cathode minus anode. What is cathode here? Ag is the cathode here. Always put the reduction potentials here. Minus E naught of anode, that is nickel, that is E naught of nickel, that is getting oxidized here, right? Always put the reduction potentials here, and here also they have given you reduction potentials, so put the values here, calculate E naught, then calculate delta G naught. Yes, okay. Now second step here is to calculate the equilibrium constant. What is the formula for equilibrium constant, everyone? What is the formula for equilibrium constant? See this. Okay, either you can just learn this formula. If you don't want to cram the formula, just learn the Nernst equation. Nernst equation is equals to E naught cell minus delta minus 0.059 by F log base 10, and this is your QC. QC is what? Reaction quotient, that is oxidation by reduction. Now at equilibrium this will be equals to 0. Okay, at equilibrium this is equals to 0. So at equilibrium E naught cell is going to be 0.0591 divided by N, and this is log base 10 Kc. Okay, this is going to be the right answer here. Okay, this is going to be the right answer here. Yes, everyone, understood this? Simply you need to put the formula and take the antilog, you will have your answer here. Yes, bacha? Okay, you don't need to cram any formula here. Just remember Nernst equation and put the value of E cell is equals to 0. Yes, okay, N is equals to 2 here. Yes, okay. Now, next question here, everyone. Next question is the resistance and conductivity of conductivity cell. The resistance and conductivity of conductivity cell containing 0.001 molar KCl solution at this much. Okay, what is the cell constant they have asked you? Okay, what is cell constant? Cell constant is equals to L by A. We don't have what is the length, we don't have what is the area. So what we will do here, we will simply put here, everyone, we will simply put here, we know one more formula, that is G into G star is equals to kappa. That means G star, which is the cell constant, G is conductance and K is the conductivity, is equals to kappa by G. What is G, everyone? What is G? That is conductance, that is reverse of resistance. So that will be kappa into resistance. This is going to be the right formula here. This is going to be the right formula here. Yeah, okay, calculates its cell constant and molar conductivity. Cell constant, now how you will calculate? This is the molarity, right? This is the resistance and this is the kappa. This is the value of kappa. Just put the value of kappa and resistance into this, you will get the value of cell constant. And next thing that we need to calculate is calculate the molar conductivity. Molar conductivity is equals to K into 1000 divided by K into 1000 divided by molarity. Right? You have the value of molarity here, right? You have the value of molarity, you have the value of kappa. Just put the values and you will have the value of molar conductivity. Yes, okay, this is your 2022 question. Now, next question here, bacha. Next question here. Calculate the EMF of the cell. Okay, this is the cell. This is going to be the oxidation half cell. This is the reduction half cell. So if I have to write here, what is anode here? Anode means zinc is losing electrons here, right? Anode means zinc is going to lose electrons here, right? And what is cathode? At cathode, what is happening? At cathode, Eg is gaining electron here. Okay, it is gaining electron here. Now, I have to multiply this by 2 because the number of electrons gained should be equals to number of electron lost here, right? So, this is the value of N is going to be 2 here. The value of N is going to be 2 here. Now, what is the value of E naught cell? E naught cell is equals to E naught of cathode. What is the cathode? Cathode is Ag here, right? Ag positive to Ag minus anode. What is anode here? Anode is zinc here. So always write the reduction potential here. That means gaining of electron here. We have given, they have provided us with the reduction potentials only, right? If they have provided us this thing, that Ag to Ag positive equals to minus 0.80 volt. So then you will convert this into reduction potential. Okay, then you will write, okay, reduction potential will be Ag positive to Ag is going to be minus of minus 0.80, that is going to be plus 0.80 volt. Okay, always write the reduction potential here, always. Yes, okay, now let us put the statement in our Nernst equation. Nernst equation we have E is equals to E naught cell minus 0.0591 divided by N. What is the value of N? N is equals to 2. Log base 10. Now, upper we have oxidation. Here we will write oxidation and here we will write reduction. Where is the oxidation at anode? Oxidation at anode we have zinc 2 positive, zinc 2 positive, and for, see this very carefully, okay, for reduction we have 2 Ag positive. That means we are going to put the value here, that is Ag positive raised to the power 2. Why raised to the power 2? There are so many atarangi colors I have used here, right? Okay, so this is going to be Ag positive raised to the power 2. Why raised to the power 2? Because we always raised to the power, because in equilibrium we know that always that is raised to the power the stoichiometric coefficient, we do that. So here also we will put the values and raised to the power stoichiometric coefficient here. Okay, so this is going to be your answer here. Calculate the E naught value from this side, put the value here, you will have your E cell. Okay, you will have the value of E cell here. Yes, bacha. Okay, any problem till now? Any problem till now? Everyone in the chat box, any problem till now? Yes, bacha, very good. Yes, I'll do the organic also. All the things I'm going to cover today. Okay? Yes, perfect. I can't see your chats here. Okay, nice. Sri Lanka, wow, very nice. So happy to know that. Yes, bacha. No, ma'am, understood. Perfect, perfect. Okay. Now we have next, that is we have completed physical chemistry. So these kind of questions are going to ask in your CBSE board exam, right? Okay, not that much high level, simply these kind of questions will be asked. You will see that in your 27th exam paper, right? Okay, now next question here is 2023 question. Which of the following characteristics of transition metal is associated with the catalytic property? Now why transition metal behave as a catalyst? Because they have variable oxidation state. That is why their ability to form complexes and the ability to show variable oxidation state. That is, D is the plus one. Okay, D is the correct answer. Next is 2023 question. Copper, if a non-transition element. Is copper a non-transition element? No, copper is not a non-transition element. Zinc, cadmium and mercury are non-transition element, right? So this is obviously false, right? Okay, so the answer is simply D. We don't need to check any other option here, but still we will check. Okay, copper has completely filled d orbital in its ground state. Is it? Yes, it has completely filled orbital. It has configuration argon 18, 4s1, 3d10. But that doesn't mean it is non-transition, because it doesn't have fully filled orbital here, right? Okay, 4s has one electron, not fully filled. So D is the correct answer. In D block, they ask you repeatedly same kind of question. The question that I am going to do today, same kind of question will be asked to you in the examination. Okay, so firstly, first question is, E naught value for Mn3 positive to Mn2 positive is much more positive as compared to Cr3 positive to Cr2 positive. Why so? If we talk about Mn, okay, Mn is 25. That is argon 4s1 3d5. Okay, for 3 positive, it should take 3 electrons. Okay, if we talk about this is 2 positive, for 2 positive it is this one. To convert it into Mn3 positive, it is very difficult to take the electrons from 3d5 configuration, that is halfly stable configuration, right? That is the reason the value here will be very high, right? Okay, the E naught value of this is much more positive. The value is going to be very high. Now we are going to talk about Cr. Chromium we have, that is 24. This is argon. This is 4s2 3d4. Yes. Yeah. Okay, this is the answer. Now, firstly, let us convert it into 2 positive. 2 positive means it will be 3d4 here, right? 2 positive means what I have done wrong. 24. No. Okay. Yes. Okay, chromium is 24. This is exceptional electronic configuration, that is 4s1 3d5. Okay, so now if I am talking about chromium 3 positive, chromium 2 positive, let us see the electronic configuration of chromium 2 positive, that will be 3d4. To take the electron from chromium 2 positive and convert it into chromium 3 positive is easy, because here it is not a half filled stable configuration. So here to convert it into Cr3 positive is easy, and here it is difficult. That is why we will have couple will have more positive value and this will have less positive value. Now second question here is, everyone, the second question here that we have, why is scandium, everyone, the second question, the B part here is, why scandium is colorless? Like scandium 3 positive means argon, scandium is 21, right? Argon 4s2 3d1. 3 positive means take all the electrons here, right? There will be 4s0, 3d0. That means no electrons, no dd transitions here. That is why it is colorless. Okay, that is why it is colorless. Now let us talk about titanium 3 positive. Titanium means you will have the atomic number 22. That is argon 4s2, 3d2. Right? Okay, take 3 electrons. 2 electrons from 4s and 1 electron from 3d. It has 1 electron. So there will be dd transition. dd transition, and hence it is going to be a colored compound. Okay, hence it is going to be a colored compound. Right? Next question you have, why actinoids show wide range of oxidation state? Why actinoids show wide range of oxidation state? Because of comparable energies of 5f, 60 and 7s orbitals, actinoids show wide range of oxidation states here. Next is complete this reaction. Next is write the chemical equation for preparation of KMnO4 from MnO2. Very important reaction. Okay, very important. This we have done yesterday, that this is MnO2, or here if you will convert it into manganate ion, then manganate ion will be converted to permanganate ion using 2 things: either electrochemical reaction or put it in the acidic medium. It will disproportionate into the manganate ion. In acidic medium, manganate is going to disproportionate into permanganate ion. Okay, this is a permanganate ion, this is manganate ion. Okay, bacha? Yes, everyone. Ma'am will half filled and fully filled. Fully filled will not show dd transition, but half filled is going to show. Yes, okay. There should be unpaired electron. For dd transition, there should be unpaired electron. Right? If it is fully filled, there is no unpaired electron. Right? Okay? Yes. Next is CBSE 23 question. First is transition metals form alloys. How can we say transition metal form alloys? Transition metal form alloys because the size are comparable, right? The sizes of the atoms are comparable here. That is why they form alloys. Next is why Ce4 positive is a strong oxidizing agent, because these Ce, okay, these lanthanoids are more stable. The most stable oxidation state is +3. So from +4 it will get converted to +3. That means there will be reduction. But if it wants to get reduced, it will be a strong oxidizing agent, right? Because if it is getting reduced, it will oxidize the other thing, right? That means it is a very strong oxidizing agent, right? Okay, that is the answer here. Write one similarity and one difference between lanthanoid and actinoid and complete this reaction. See this? Okay, one similarity. Similarity is both are stable in +3 oxidation state. This is the similarities here. Why lanthanoids show complex which complex chemistry? I can't see your comment. I can't see your comment. There is something in your comment. Which chemistry are you showing? More complex chemistry. Because bacha, the sizes, the trends are very invariable, right? Very invariable trends. There is no particular trends here. That is why we do not study that much lanthanoids and actinoids. Okay, we have detailed transition metals, right? Transition metals are also not showing that much of trends here, but yeah. Okay. Okay, perfect. Next we have difference is lanthanoids are mainly non-radioactive, whereas actinoids are radioactive in nature. Next is complete the reaction. So this is your dichromate ion. Dichromate ion in basic medium, this converts into chromate ion. Okay. In basic medium that we have done yesterday, okay, how dichromate ion behaves in alkaline and in acidic medium. In alkaline medium, dichromate ion is shifted towards chromate ion, right, showing a yellowish color, right? This is of orange color. Yes, bacha, understood this? Next is CBSE 2022 question. Transition metals and the compound show catalytic activities. Why catalytic activities? Because of variable oxidation state and the ability to form complexes, right? Next is zinc, cadmium, mercury are non-transition elements. Why they are non-transition elements? Because in ground state as well as in excited state, they have fully filled 3D orbitals. They have fully filled 3D orbitals, right? Okay, and they will ask you why silver is why silver is a transition element. It has 3D10 configuration because silver in its excited state do not have fully filled orbitals, right? Okay, next question is zirconium and hafnium almost identical radii. This is because of lengthenoid contraction. This is because of lengthenoid contraction. Okay, this is because of lengthenoid contraction. They show similar radii. Okay, the orbital of the 4D and 5D series have similar radii because of lengthenoid contraction. They can also ask you why. They can also ask you one more thing, that is why which is more, actinoid or lengthenoid? So actinoid is more as compared to lengthenoid contraction. As compared to lengthenoid contraction. What is the reason behind that? Because 5f orbital has very less shielding effect as compared to 4f. Okay? Because of 4f. What is the reason behind lengthenoid contraction? Because f orbitals have very less shielding effect as compared to s, p, d, n. Okay? The shielding effect order is always s, then p, then d, then you have f. Okay? Understood? Yes, bacha? Okay, bacha? Beta spin is always plus half and minus half. Are you talking about the multiplicity? Multiplicity is not in your syllabus. Okay? Multiplicity is not in your syllabus. Okay? Yes. Now, next question here is, now these two questions are totally reaction based questions. Okay, from your K2Cr2O7 and KMNO4, both were asked in 2019. Okay, so I will tell you what kind of question were asked in 2019. This was a question on K2Cr2O7, that is potassium dichromate, where they showed you these 4 reactions you have to identify, right? This is because of the colors that you were able to identify these. I would consider this was a tough question. Okay, this was a tough question because cramming these reactions is a little bit difficult, but because this is your previous year question, you have to, you have to go through this, right? Okay, so this is your FeCr2O4. This is where you're going to convert it into sodium chromate, then to sodium dichromate, then sodium dichromate to potassium dichromate, then potassium dichromate with reaction with Na2SO3, it is going to convert it into chromate sulfate. Okay, chromium sulfate. Okay, these are the reaction, these are the preparation step, and these are the reactions, and these are the reaction of potassium dichromate. Okay, understood this? Very important. As it is, you have to learn this. I'm so sorry about it, but I can't do anything about it, right? You have to learn this, right? I can make you understand this because these are simply reactions. Okay, these are 3-step reactions of formation of potassium dichromate. Now, if we talk about, same question was asked in CBSE 2019 in the same year. That was for potassium dichromate, right? That was for potassium dichromate. There's very less probability that they will ask this question, but yes, they have asked this question just 4 years back. Okay, 4 years back they have asked this question, so there is probability that they can ask you. But yeah, there is no frequency, there is not that much frequency of asking these reactions, but they have asked this. Okay, so now these 3 are the steps, these 2 are the preparation step. These are the preparation steps of potassium permanganate, that firstly convert it into permanganate ion, that is of green color, then convert it into firstly make the manganate ion, that is of green color, then after acidification that will be converted into potassium permanganate ion. Okay, how to convert manganate to potassium, how to convert manganate to permanganate? There are 2 ways. First is electrochemical process, second is acidification. It will disproportionate to form permanganate ion, right? Now these 2 are very important, very important question. Very important question for any examination. For any examination, these two questions are very important. Now, you have potassium permanganate. Now, potassium permanganate has oxidizing property. In case of alkaline solution, that is in case of basic solution, Ki is converted into this. Right, what I am writing here? In case of basic, I negative is converted into IO3 negative, and in case of acidic, I negative is converted into I2. Now this is a very important question, okay? Very important question, that in basic and alkaline medium, I negative is converted into different things, okay? Understood? That is why this is asked, and this is high probability that they can ask you this question, okay? Yes, bacha? Yes, perfect. There are so many reactions in K2Cr2O7, potassium dichromate and potassium permanganate. But if you don't want to go through all the reactions, just go through these two questions. This one question and this question and this question. Just go through these 8 reactions. If you don't want to do all the reactions, just go through these 2 questions, okay? Always do this, okay? Yes. Next is coordination compounds. Next we have coordination compound. Everyone here, what is the answer to this one? What is the answer to this question? What is the answer? The formula of the complex dichlorido bis, okay? This is dichlorido bis, that means 2-ene. And then you have platinum, that means Pt, and then you have nitrate here, that is NO3. Now what is the oxidation state here? Oxidation state is 4 plus, this is minus 2 and this is plus 0, right, equals to 2. That means this whole is going to have 2 here, that is plus 2. And if it is having plus 2, there will be cross valency, that will be 2 will be in the downside of nitrate ion, okay? Understood? Yes. So the answer, no, C is not the correct answer, bacha. B is the correct answer. B is the correct answer. Why everyone is writing C? There is ligand have 2 chlorido bis in. These are the ligands, right? These are the ligands. This is the center metal atom. This is the counter ion. Okay, this is the counter ion, right? Okay, this is the counter ion. And after calculating the oxidation state, the positive charge will be plus 2. After cross valency, there will be 2 on the downside of NO2. Right? Okay? Yes. On the subscript of NO3, there will be 2 here. Right? So B is the correct answer. Next is draw the geometrical isomers. Draw the geometrical isomers of this one. Which geometrical isomers is not optically active and why? Okay, firstly let us draw the geometrical isomer here. Okay, I'm going to copy this one because there are 2 parts to it. Okay, so firstly draw the geometrical isomer here. Let us draw the geometrical isomer. This is CO, right? This is octahedral. This is Cl. This is Cl. This is En and this is En. This is the trans isomer, right? And the other isomer is octahedral. This is En, this is En, and this is Cl, this is En. This is the cis isomer here. This is the trans isomer, this is the cis isomer. So now, out of this, which is, draw the geometrical isomer which is not optically active, right? This is going to form an image that is superimposable. So this cis is going to be non-active, okay? Not optically active, or we'll say optically inactive. Here I am going to write optically inactive, right? Optically inactive. Because it is going to form, this cis isomer is going to form the mirror image that is superimposable. This is going to form the mirror image that is this is going to form that is non-superimposable. That means enantiomer. That means enantiomer. And this is going to form the mirror image that is superimposable. That means there will be no optical activity. Right? Yes? Perfect. Next question here is, write the hybridization and magnetic behavior of COF6 3 negative, right? F6 3 negative. Everyone here? Now, this is a weak field ligand, so there will be no pairing. There will be no pairing. First thing, the oxidation state will be -6 -3. That means X is equals to +3, right? Okay, this is -1, a negative ligand, so oxidation state is +3. So now let us see. Iron on 26 have electronic configuration 4s2 3d6. Fe2 positive 3 positive is going to have the electronic configuration, that is argon 3d5. Okay, so there will be no pairing here. There will be no pairing here, right? This is S and this is P. The ligands here are 6 ligands. The ligands here, we have 6 ligands here. We have 6 ligands here, right? Okay, 1 2 3 4 5. Right, we have 6 ligands here, that is 1 2 3 4 5. No pairing here, so it will be sp3d2. It will be sp3d2 is the correct answer here. Okay, the answer here will be sp3d2 is going to be the correct answer here. Yes. Okay. Oh, big mistake I have done here. Big mistake. So sorry, I thought it is Fe here. Okay, no worries. Cobalt is 27. That means it is argon 18, 4s2, 3d7. Right? Okay. Yes. Okay. Now cobalt 3 positive is going to be argon. This is 4s0, 3d6. Right, so here we are going to have, very good bacha, thank you so much for correcting me, thank you so much. Right, sometimes in hurry I do this silly mistakes, right? Okay, yes, so this is 1 2 3 4 5 6, and again it is going to be sp3d2 configuration. That means it is going to be outer octahedral complex, sp3d2 configuration, hybridization. And now, will it be paramagnetic or diamagnetic? It has 4 unpaired electrons, so it is going to be paramagnetic. Yes, it is going to be paramagnetic. Yes, bacha? Okay. Yes, that was cobalt. Yes. Okay. Understood? Yes. Perfect. Now, let us see the next question here. The next question here is this. Calculate the hybridization and magnetic moment. This is asked in 2022. So everyone along with me solve this. First is nickel Cl4 2 positive. Okay. First is nickel Cl4 2 negative here. Right. Okay. Right, first see, have I done it right? Yes. Okay. So now oxidation state. This is a weak field ligand, so there will be no pairing. No pairing. This is going to be paramagnetic. Okay, there will be no pairing. Right. Now let us see the hybridization here. Right. This is x minus 4 is equals to -2. X is equals to +2. Right. X is equals to +2. Yes. Now you have this one. 1 2 3 4 5 S. This is going to be P, this is going to be D. This is going to be D. 1, 2, 3, 4, 5. Right? Okay. We have 4 ligands here. Okay. You don't need to write it here. There will be no pairing. Let us see the nickel 2 positive electronic configuration. Argon 4s2 3d8. After losing 2 electrons, it will be 3d8. Right? 1, 2, 3, 4, 5, 6, 7, 8. So the hybridization here is going to be sp3 hybridization, and it is going to be a paramagnetic compound. Okay, it is going to be a paramagnetic compound because of the electrons, unpaired electrons. Yes, yes, bacha, you will definitely get the PDF. Yes, okay, okay, perfect. Now next that we have here, next is copper NH363 positive. Copper NH363 positive. Okay. Copper NH363 positive. Here simply X is going to be X minus. This is +0 is equals to +3. That means cobalt 3 positive. Argon 18. Sorry. Argon 18. 4s2. 3d This is going to be copper. This is 3d27. This is 3d7. And after losing 3 electrons, it is going to be 3d6 here. Right? After losing 3 electrons, it is going to be 3d6 here. Okay? Now, 1, 2, 3, 4, 5. 1, 1, 2, 3. Again, this is 1, 2, 3, 4, 5. Now, NH3 is a strong ligand. There will be pairing. There will be pairing of electrons. So that means it is going to have 1, 2, 3, 4, 5, 6. And the hybridization here will be D2sp3. And this is going to be a diamagnetic compound. This is going to be a diamagnetic compound having inner octahedral hybridization. Yes? No, not sp3. I think you are talking about the previous one, right? This is 6 ligand. 6 ligand, either it can be D2sp3 or it can be sp3d2. Okay? Yes? Okay, bacha? Now, the third one here is Fe6 3 negative. Fe6 3 negative. Okay? Fe6 3 negative. Here, no pairing will be there because of weak field ligand, right? Next is we have x minus 6 is equals to minus 3. That means x is equals to plus 3, right? Next we have, this is 1, 2, 3, 4, 5. This is S here, this is P here, and this is D here. 1, 2, 3, 4, 5. Right? Okay. Now, let us see this. The electronic configuration Fe will be, that is 26. It is argon 4s2 3d6. After losing 3 electrons, it will be 3d5. 2 electrons from 4s, 1 electrons from d. Right? So there is no pairing. It will be 1, 2, 3, 4, 5. And this is going to be sp3d2. This is going to be sp3d2 and it will be paramagnetic in nature. sp3d2 and it is going to be paramagnetic in nature. Okay? Yes, yes everyone? Understood this? This is going to be octahedral, outer octahedral configuration here. Yes, bacha? Okay. Understood this one? Any problem in these 3 questions? Any problem? We have completed the 3 parts here. Any problem here? Okay, shall we move ahead? Yes, everyone, shall we move ahead? Next question that you have. Write the IUPAC name of the following complex. You have to write the IUPAC name here. Now write the IUPAC name here. How do you write the IUPAC name here, bacha? How do you write the IUPAC name here, everyone? A part I am going to write it here. Firstly, cation you have to write. That is tetraamine, amine with double M. Then you have aqua, then you have chlorido. Because it is a negative ligand, that is why we will write it as chlorido. Next is cobalt. Now what is the oxidation state here? This is X plus 0 minus 1 is equals to, this is going to be, this is plus 2 is equals to plus 2. So it is going to be X is equals to plus 3. Right? So in Roman I will write it here plus 3. Okay, I'll write here plus 3 in Roman, that is 3. After that, this is chloride. Okay, this is chloride. Okay, this is going to be the name here. Right, that is tetraamine aqua chlorido cobalt 3 chloride. Okay, this is the IUPAC name here. Next is, what is the difference between ambidentate and bidentate ligands? What is the difference? What is the difference? Both have 2 donating sites. Okay, ambidentate and bidentate difference is that in bidentate ligands you have 2 donating sites and both are participating, both are donating at the same time. But ambidentate is that where you have 2 donating sites but only one thing is donating at a time. That means, for example, if I am talking about ambidentate ligand, if I am talking about ambidentate ligand, that will be, ambidentate ligand will be This is I am writing bidentate. Okay, this is I am writing bidentate ligand. Right? So ambidentate ligand is, for example, En. That is this one. That is CH2. CH2. This is NH2. This is NH2. Right? This is your ambidentate. This is your bidentate ligand. Sorry. This is your bidentate. CH2. CH2. This is NH2. This is NH2. Okay, it has two donating sides and both are donating at one time. For example, you have oxalate, okay, C2H4, 2 negative. This is also donating from two donating side at one time. But if you have NO2, that is sometimes donating for N and sometimes donating from this one. If you're talking about SCN, okay, this is also ambidentate ligand here. Right? Okay, everyone. Paramagnetic is having unpaired electron, diamagnetic which do not have any unpaired electron. Yes? Okay? Yes, perfect. Next is, okay, they asked you another question, that is, out of this and this, which complex is more stable? This is going to be more stable due to chelation effect. Due to chelation effect, it is going to have ring and it is going to have more stability as compared to this one. Right? Because in chelation, what you have, in chelation you have something like this. This is a metal, this is octahedral complex. Chelation means you have ring kind of structure, right? Otherwise, in normal ligands, you have this kind of ligands, right? These kind of ligands, they do not show any ring kind of structure. So this is going to be more stable as compared to normal ligands. Okay, bidentate ligands are going to provide chelations, ring stability. That is why they are going to be more stable. Okay. Okay, now we have next question. Everybody in the chat box. Yes. Okay, I assume you can answer this question. I assume you all can answer this question. Yes? Yes, bacha, try to solve this question. Okay, try to solve this question yourself. Yes, try your best to solve this question. It's a very simple. From Werner's theory, I think you will be able to solve this. Is it necessary to mention outer and inner octahedral, ma'am? Bacha, if they have asked you, yes, that is. If you know that you will get to know that after calculating it only, na. If you know that this is sp3, you write inner octahedral. Right? The examiner will get impressed that the person knows that this is inner octahedral, this is outer octahedral. Yes? Okay? Rakesh is saying A is the... why you are having suicidal thoughts? This is just an exam. Right? This is just an exam. This exam is just to prove that you are a hardworking person. Right? This will, these exams, why I am so much passionate about, working hard. Because, I have trained my mind according to that. When I was in school, I used to prepare for my exam. This is always I used to do this. I used to prepare well for my exam. But I never used to take that much stress. Like, okay, what will happen if I don't do this thing right or this thing wrong and all that. I never took that kind of stress in my entire life. Okay, what's the reason? But if you have given your 100%, rest is upon God. Rest is like upon God. The marks are good or bad, that doesn't matter. The thing that matters is how much the hard work that you put into your exam. What's the mental state? How you are able to handle your stressful situations. Exams are to make you deal with all these things. How to do hard work, how to handle stress in your life. If you don't know how to prepare for exam, you will never be able to prepare for your life, right? If you don't know how to do hard work, even if you want to be a singer or cricketer, nothing you will be able to achieve because you don't know how to do hard work, right? So just relax, just focus on the things here and just give your exam, okay, with the relaxed mind. Okay, yes. Okay. Now next question is 1 mole of Cr. Welcome bacha, welcome. Okay. Thank you bacha, thank you Samarth, thank you so much. Thank you beta, thank you so much. Thank you so much for your love. Thank you so much. Means a lot to me. This means like the world to me. You know what? All your love, this means the world to me. This is the reason why I am standing here, right? Okay, thank you so much. Thank you so much. Okay, so now let us see this. 1 mole CrCl2. Now they have given the lesson that after adding AgNO3, AgNO3 on reacting with Cl negative ion is going to produce this AgCl precipitate. So they are saying we have 2 moles of AgCl precipitate. That means outside the coordination complex you will have 2 Cl negative ions. That is, this is having 3, this is having 1, this is having no Cl negative, this is having 2 Cl negative ion. So this is going to be the right answer here. Okay, yes, perfect, perfect. Okay, now the next question here is, everyone, next question, using IUPAC norms, write the formula for the following complexes. So everybody in the chat box, yes, you will definitely top. Yes, my blessings are with you. Just concentrate on your exam, okay? So this is a hexaquachromium. Hexaqua means you have water that is having 6 ligands, and because we have written it in front side, that means this is coordination square is the cation here, right? This is the chloride here, and this is the hexachromium. This is chromium. Now let us find the oxidation state here. This is having 3 oxidation, right? This is having 0 number, this is a neutral ligand, is equals to what? This is 3, right? That means there is 3 positive here. If in the coordination complex, in the coordination sphere, you have 3 positive here, after cross valency you will have Cl3 here, right? After cross valency you will have Cl3 here. Now B part is sodium trioxalate ferrate. Now see this is ferrate. What does this mean? Everyone in the chat box, what does 8 means? If you have central metal atom, central metal ion, that is regarded as, that is referred to as 8. That means the central metal ion, the complex quantity, like the complex entity is in the anionic state. Okay, this means we will have anion here. Okay, this is going to be in the anion part. This is the sodium here. Okay, this is the sodium. Very good bacha, very good. This is the sodium, this is the ion, right? This is trioxalate, this is trioxalate. So now let us see the oxidation state. Iron in +3 oxidation state. Oxalate is having -2 charge. Okay, so this is going to be -2 into 3 equals to, this is 3 minus is equals to -3. That means this complex is going to have -3 charge. If it has -3 charge, by cross valency you will have, 3 here, 3 in the subscript, right? Okay, understood? Yes, perfect. Now this is going to be the right answer here. Yes, bacha. Now next is, we have answered it. Next question is, we have completed physical chemistry, we have completed inorganic chemistry. Yes bacha, the josh is high. How's your enthusiasm, everyone? How's your enthusiasm, right? Okay, everyone in the comment section, green hearts in the comment section. We are going to start organic chemistry now. Everyone, green hearts in the comment section. Have you seen one thing? I usually complete in one class, I complete this one bottle. Now what is the method behind that? Why I do this? Right? Because if my mind is dehydrated, I will not be able to concentrate, right? So I will, all the students there, yes bacha, always keep this water bottle with you, right? Always keep this water bottle with you. This is going to help you a lot to maintain the concentration, right? Okay, yes. Okay bacha, yes. Bacha, I don't study in college, right? I don't study in college. It's been a while that I have studied, right, in college. Okay, green apples, and I'm going to take that apple. Okay, I'm going to eat that apple because apple a day keeps the doctor away. But I don't want you doctors to be away from me. So I'm not going to eat the apples now, right? Okay, now let us see this. Well, now illustrate the following reaction given suitable examples. Okay, yes bacha, sample papers they have asked about polymers, ma'am, what to do? Polymers, is it? Leave that, don't take stress about it. Okay, do not take stress about it. Yes bacha, do not take stress about polymers. Leave that. Okay, yes. Now, next is Gabriel phthalimide synthesis, carbylamine reaction, Hoffman bromamide reaction. Okay, these two are for primary amines. This is from primary amines. Primary amines. This is for also primary amines. All these three are the reactions, the most important reactions from amines chapter. Let us see one by one. This is Gabriel phthalimide reaction, where you have phthalimide firstly reacted with KOH. This H will be converted to K. This will be positive. This will be negative, and this will be K positive. After reacting with alkyl halide, it will be replaced by R here, right? After reacting this with NaOH, aqueous NaOH, the bonds, these two bonds will be broken down, and you will have primary amine and phthalic acid. Okay, this is applicable for primary amines only, right? This is the first reaction. Second is bacha, we have carbylamine. Okay, what is carbylamine? This is a distinguished test where isocyanide is formed having very foul smell, having very foul, weird smell, having very foul, bekar smell. Okay, so now this is not applicable to secondary or tertiary amines. Okay, this is not applicable to secondary or tertiary amines. This is applicable to primary amines, whether it's aliphatic or it's aromatic, right? Okay, so now what do we use here? We use same reagents that we use in Reimer-Tiemer reaction, that is chloroform with KOH, right? And it is going to form an electrophile, that is CCl2, that is dichlorocarbene. This is dichlorocarbene, and this dichlorocarbene, everyone, this dichlorocarbene is the electrophile here. Okay, this is the electrophile here. Yes bacha, okay, understood everyone? Perfect. Next is preparation of primary, that is Hoffman bromamide reaction. We have this amide here. This will be converted to RNH2. We will just, this CO bond, this carbonyl bond will just vanish from this side. Okay, so we will have a amine that is having one carbon less. Okay, that is RCONH2 will be get converted into RNH2. Here the reagents are Br2 and NaOH, and this is called Hoffman bromamide degradation, because here the carbonyl group just vanishes. It is getting degraded. That is why it is called Hoffman bromamide degradation. Okay, yes everyone, JM Nakate, kindly please don't spam here. Okay, it's a request, please don't spam here. Okay, understood? Please don't spam here, otherwise I'll have to block you, right? Okay, yes. Now next question here is, arrange the following in the increasing order of boiling point. Now to do this in the increasing order of boiling point, yes bacha, increasing order of boiling point, what is going to be the correct answer, right? For increasing order of boiling point, that means hydrogen bonding. Let us see this. Okay, this tertiary amine has no hydrogen, that means no hydrogen bonding. This is having oxygen and this is having nitrogen. We know that hydrogen bonding of oxygen is more than nitrogen, so it is going to be, if I say this is the first, this is the second, this is the third, so hydrogen bonding will be maximum in second, then in third, then in first. Okay, this is going to be the right order. That means the maximum hydrogen bonding, the maximum boiling point is of alcohol, then you have primary amine, then you have tertiary amine. Yes, okay, very good. Now next thing that we are going to talk about, maltose is made up of what kind of things? Alpha D glucose and beta D glucose and fructose, D fructose. Now let us talk about this. Okay, when we talk about sucrose, this is made up of glucose, this is made up of glucose and fructose, right? If we talk about lactose, it is made up of galactose and glucose, okay? Galactose and glucose, right? And if we talk about maltose, maltose is made up of 2 units of alpha D glucose, right? 2 alpha D glucose, right? Here we will have C1 C2 linkage, here we will have C1 C4 linkage, and here we will have C1 C4 linkages, glycosidic linkages, right? Okay, so it is alpha D glucose is going to be the correct answer here. Next we have amino acids which cannot be synthesized in the body, like which you have to take from outside, are called essential amino acids. So B is going to be the correct answer, right? Next we have the base which is present in DNA but not in RNA, right? Now everyone here, if we talk about DNA, DNA is at college, DNA is at college, at government college. You want to take admission in government college, no? So you want to take admission in government college because the expenditure is very less, right, in government colleges. So this is AT, adenine thymine, okay? Adenine will be hydrogen bonded to thymine and guanine will be hydrogen bonded to cytosine. This is in DNA, right? This is in DNA. Yes, this is in DNA, right? Okay, when we talk about RNA, in place of thymine there is uracil, rest is same, okay? In place of thymine you have uracil, that is AU will be hydrogen bonded and G and C will be hydrogen bonded to each other. Yes, very good bacha, very good, very good. So this is which is present in DNA but not in RNA. D is going to be the correct answer here. Next is nucleic acids are polymers of, right? Now what is amino acids polymer is protein, okay? Protein. Glucose polymer is nothing. Glucose polymer is maltose. Maltose. Yes, maltose. Yes, maltose. Now what is nucleoside? Nucleoside is sugar plus base. Plus base. And nucleotide is sugar plus base plus phosphate group. Plus phosphate group. Right? Plus phosphate group. Right? Okay. So nucleic acid are the polymers of nucleotides. That is C is the correct answer. Yes, very good. Okay, bacha. Okay, now next we have complete the following. Okay, curdling of milk. This is what? This is denaturation of protein. Okay, this is denaturation of protein. B and A and C cannot be the right answer. Next is, this is a alpha helix structure. Alpha helix structure is a primary structure, secondary structure, tertiary structure or quaternary structure. Alpha helix is a secondary structure, okay? That is alpha helix or beta period is a secondary structure, right? So D is going to be the right answer here. Yes, D is going to be the right answer here. Yes, okay. What about the sugar moiety? Bacha, in RNA you have ribose sugar, in DNA you have 2-deoxyribose sugar. Okay? Yes? Okay. What are, guys, please concentrate here, okay? Please concentrate here. Please, okay? Here. Now peptide linkage is present in. Peptide linkage is present in carbohydrates you have glycosidic linkages. Glycosidic linkages. Okay? In proteins you have peptide linkage of amino acids. Right? So C is going to be the correct answer here. Yes, C is going to be the correct answer here. Next is, what is the basic structure difference between starch and cellulose? Now see this very carefully. What is the basic difference? What is starch? Starch is made up of two things, okay? Starch is made up of two things here. Starch is made up of two things. First is, everyone, first thing here is, two things here. First thing is amylose. Second is amylopectin. Amylopectin. Okay, right? Okay. Now amylose is having, this is linear. It has, this is branched. Okay, this is branched. Now amylose is having C1 C4 glucose linkages of alpha D glucose. It is having C1 C4 plus C1 and C6 linkages of alpha D glucose. Right? Okay, this is about starch here. Okay, this is about starch here. Now if we are talking about, everyone, if we are talking about okay, if we are talking about what? If we are talking about this one, that is cellulose. For cellulose, everyone, this is made up of beta D glucose. Okay, this is made up of beta D glucose. Okay, this is made up of beta D glucose, and this beta D glucose is having C1 C4 linkages of beta D glucose. Right? Okay, that is the difference here. Yes, everyone, this is the difference here. Yes, bacha. Okay, understood this? Okay, bacha, understood this? Yes, beta. Yes. And for starch, very good. This is alpha, this is beta. Okay. Now, also one more thing. If we talk about glycogen, it is just more branched, but same as amylopectin. The spellings may be wrong here, right? Okay, it is a animal tissue. And this cellulose is a plant tissue. Okay, animal tissue means when we need energy, this glycogen is getting converted to glucose to provide us with the energy here, right? Okay, this glycogen is converted into glucose to provide us with the energy at that point, right? Okay, these are the difference. This is a starch, this is the cellulose. Yes, everyone, got this? Should we move ahead? Yes, bacha. Everyone in the chat box. Yes, bacha. Next we have write the products obtained after hydrolysis of DNA. After hydrolysis of DNA, you will have three things, because DNA is made up of three things. That is ribose sugar. Second is phosphoric acid. Now, third part is the bases. And what are the bases? You will have adenine, thymine, guanine and cytosine. These are the bases that you will get after hydrolysis of DNA. Okay, if there is RNA, this will be wait, this is not ribose, this is 2-deoxyribose. Okay, if they talk about RNA, this will be ribose, and here it will be adenine, uracil, guanine and cytosine. Okay, understood? Yes. Okay, so all this is written in the form of paragraphs here. Now one more tip for your CBSE exam, always write things in points. Okay, few tips here, few tips for your CBSE exam here, everyone. Few tips for your CBSE exams. Okay, tips for your CBSE exams. First write in points. Okay, write the answer in points. As many flow charts and diagrams. Okay, this will fetch you more numbers. Like I have written this in flow chart. Okay, if you have written this part in the form like this, okay, in the form of this kind of flow chart, they will give you full marks for this. Okay, just write 2-3 pointers, lines and mention in the form of flow charts. You are going to get full marks. Trust me on that. Okay, yes. Okay, now, yes. Third is always there should be space between the answers, right? It should be well presented. If you're focusing on these 2-3 points and do not do any cutting, if you're cutting something, for example, if you're cutting something, you have written something like you have written ribose and you want to cut it, do not cut it like this, do not cut it like this, okay? This is the wrong way. If you're cutting something, completely cut it like this, okay? Cut it like this. Do not use fluid or anything, do not use anything, just cut it like this, simple, okay? They will understand, right? Okay, and avoid that thing, avoid as much as you can, right? Now next question that you have, what are the product of hydrolysis of maltose? What are the product of hydrolysis of maltose? For maltose you have two things, that is, it is made up of what? Two things, alpha D glucose, right? It is made up of two things, that is alpha D glucose, okay? It is made up of two things, that is alpha D glucose here. Next is, what type of bonding provides stability to alpha helix structure of protein? That is hydrogen bonding provided the stability. Next is, name the vitamin whose deficiency causes pernicious anemia. What is that vitamin that causes pernicious anemia? That is vitamin B12 causes pernicious anemia. Okay? Yes, bacha? Very good, very good, very good. Now, second is, next question here is, define the following terms. What is invert sugar? Invert sugar is nothing but sucrose, okay? Invert sugar is sucrose, because here it is dextrorotatory. It will give you glucose and it will give you fructose. Now glucose is also dextrorotatory, that means it is D. This is also D, but fructose is levorotatory. But the amount of fructose is more as compared to glucose, right? So that is why it is getting inverted to dextrose to levo, dextrorotatory to levorotatory. That is why it is called inversion of configuration. That is why it is called invert sugar. Okay, that is why it is called invert sugar. Yes, bacha, very good. Next part is native protein. Now, what is native protein? That is actually in the biological system. See the definition here. Protein found in the biological system with a unique three-dimensional structure and biological activity is called native protein. Okay, that is called the native protein here. Yes, bacha, you will get the PDF. Next is nucleotide. What is nucleotide? When you have sugar, then plus base plus phosphate group, okay, this is called nucleotide. What is nucleoside? When you have sugar and base, that is called nucleoside. Yes, everyone, perfect. Now, what is the difference between amylose and amylopectin? We have already done that. Amylose is a linear, this is a branch, this is having C1, C2, C1, C4 linkages, this is having C1, C4 plus C1, C6 linkages, that is glycosidic linkages. That is why it is branched. Very good, that is why it is branched and this is linear. Okay, and the glycogen is a more branched version of amylopectin. So the structure is similar, but there is more branching in glycogen. Okay, yes. Now, same things they have written here. Okay, this is about alpha D glucose. Also write it. What are the linkages? This is about alpha D glucose. Yes, bacha. Now, next part here is, write the products obtained after hydrolysis of lactose. After the hydrolysis of lactose, lactose is made up of galactose and glucose. Okay, lactose is made up of galactose and glucose. Very good, Gry finder, very good bacha, very good. Okay, so after hydrolysis of lactose, you will have galactose and you will have glucose, right? Okay, you will have this galactose and you will have glucose here. Okay, this is the lactose, right? Okay, yes. Next we have, everyone, so these are the question from your reactions of glucose, from the reactions of glucose. These are the question from reactions of glucose. Write chemical reactions to show that open structure of D-glucose contains the following. Okay, write this to show this. Everyone in the chat box. Straight chain, 5 alcohol groups. Aldehyde has a carbonyl group. So now, if I want to show that your glucose is having straight chain, you will react this with HI. Now it will form N-hexane, and hence we will say that this is formed of 6 carbons in the straight chain. Right? This is the first reaction. Now if you want to show that glucose is made up of 5 hydroxy group, like react this with acid anhydride, then OH will be converted to OAC, where AC is the anhydride acetyl group here, right? AC is the acetylation. Very good. AC is the acetyl group here, right? So here 5 OH is converted to 5 OAC. That means we have 5 OH groups here. Now we don't know which is primary, which is secondary, right? Next thing is to find out that aldehyde has a carbonyl group. If you want to find out that it is a carbonyl group, for carbonyl group you need to react this with NH2OH, or you need to react this with HCN. You will have the reactions of aldehyde. Okay, you will say that okay, it has carbonyl group. If you want to confirm that this is a aldehyde group, what you do here? Use any good oxidizing agent, either HNO3 or Br2 water. This will give us that it is having CHO group, because CHO will be converted to COOH, right? Okay, this will show that you have aldehyde group here, right? They have reacted this with Br2 water. You can also use HNO3, right? Oxidation, the CHO will be get converted to COH, which is called gluconic acid, right? Okay, bacha? Yes, beta. Very good. Do we have to work out those problems? You can, if you have time. I would really advise you have just one day left. I would really advise you to revise the whole syllabus again and again and again. Okay, because the questions that I have done here, and you can go through your NCERT questions, and that's it. Okay, if you're able to solve this, that's it. You don't need more of the questions. Okay, yes. Okay, ma'am, the NCERT question which you gave as important alone enough. Which the short that I have made, are you talking about, Krishna? The short that I have made for you, the NCERT important question. If you're doing that, those NCERT question plus these PYQ questions, that is enough for you. Okay, just revise the syllabus. Okay, you don't need to, just one day left, just relax now. Okay, one day left, take proper sleep, do what I am asking you to do, revise the formulas again and again and again, revise the naming reaction, revise the distinguished test, revise the formulas, revise the trends. Now it's a time for revision, revision and revision. Okay? Yes, bacha? Very good, very good. You need to revise again and again and again and again. Okay? Yes. Next is write the reaction involved in D-glucose treated with the following reagents. Okay, now write this, bacha. Yes, bacha, I'll definitely. How many times are you going to ask me this? Huh, you Logesh? I will provide you PDF. You don't trust me? You don't trust me? Trust me, na? Yes. Okay. Now, write the reaction involved in D-glucose is treated with the following reaction. First is bromine water, next is this and this. Now tell me this thing. Okay, bromine water shows that there is presence of CHO group, right? This shows that there is presence of carbonyl group. Okay, this shows that there is presence of 5 OH group. Okay, let us write the reactions here. Now, bromine water, CHO is getting converted to COH, right? CHO is getting converted to COH. Then you have with hydroxylamine, it is going to show the reaction for aldehyde and ketones. That means this is going to get converted into CH double bond. That means this kind of reaction is showed by aldehyde, no? This kind of reaction is showed by the carbonyl group. This is converted to C, this is double bond, this is N and this is Z. Okay, the same reaction it is showing. Okay, very good. Now, next is the reaction with OAC. OH will be converted to OAC. Right? Okay, AC is the, AC I am talking about the acyl group here. Okay, here OH is going to convert into OAC. This is actually easy to remember. Why I always tell student to remember OH is getting converted to OAC, because this is easy to remember. Acetyl group, you know, that is COCH3. Okay, yes. Next is bacha, everyone here. Oh, you have not disappointed me, beta. You have not disappointed me. Don't worry. Okay, I will provide you that. Okay, that is my responsibility. Okay, bacha. Yes, beta. Now, next thing is given equation of the following reaction. Let us see the reactions of this. First is phenol is treated with concentrated HNO3. When phenol is treated with dilute HNO3, it will form ortho and para product, different products, and para being the major product. But with concentrated HNO3, it is going to form picric acid. It is going to form picric acid, that means 2,4,6-nitrophenol. Okay, same with bromine water and bromine CS2. With bromine water, it is going to form 2,4,6-bromophenol, and with bromine CS2 in non-polar solvent, it is going to form ortho and para product, different products. Right? Okay, yes. Next is propene is treated with B2H6 followed by this. This is hydroboration oxidation. Anti-Markovnikov rule is going to apply here. Next you have sodium tert. This is Williamson synthesis. This is Williamson synthesis, right, for ether. For the formation of ether. Next is, how will you distinguish between butane 1 and this? You will distinguish this with Lucas test, okay? With Lucas test. Arrange the following increasing order of acidity, right? Increasing order of acidity. Let us see this one by one. Everyone, let us see all these questions. Okay? Yes, bacha? Bacha, anomers are cyclic epimers, okay? They are cyclic epimers. When you have last chiral carbon, that is different. That is anomeric carbon, okay? That is anomeric carbon. When you have two structures where last chiral carbon is different, the configuration is different, okay? That is the anomeric structures, anomers, and that carbon is anomeric carbon, okay? Yes? Now, next is, phenol is treated with concentrated HNO3 to obtain, you will have 2,4,6-trinitrophenol. Next is, propene is treated with B2H6, and this is hydroboration oxidation. So OH will be applied to the more number of, that is anti-Markovnikov means negative part to more number of hydrogens here. So you will have propene 1 ol here. Next is methyl tert-butyl ether is produced when sodium tert-butoxide is treated with methyl chloride. So here you have methyl chloride. Here this CH3 is going to attack here, and you will have the formation of ether by Williamson synthesis reaction. Okay, by Williamson synthesis reaction. Okay, yes. Next part is they have written butane. This is with butane. Okay, this is butane. Okay, butane 1 ol and 2 ol will be okay. Lucas reagent for 1 degree, for 2 degree, with 3 degree. Lucas reagent is ZnCl2 plus HCl with 1 degree. Okay, with 1 degree, it will give turbidity after prolonged heating. That too after 30 minutes. For 2 degree it will give turbidity after 5 minutes. With 3 degree it is going to give turbidity immediately. Okay, it is going to give turbidity immediately. Okay, yes bacha? Yes, okay, yes. Now increasing order of acidity. So now here phenol has 5 resonating structures. That is why it has maximum acidity. Then water. Then you have ethanol here. Yes, bacha? Okay, everyone? Perfect. 1 degree we say almost no turbidity only. Yes. Next is, how can you obtain phenol from cumene, from benzene sulfonic acid, from benzene diazonium salt? Right? These three most important preparation step of phenol. Right? Okay. This is Cole's reaction. Write the structure major product obtained from dinitration of this. Okay, let us see these three questions here. Firstly, you have, this is isopropyl benzene, which is called cumene, which common name is cumene. Now this is a very important question, very important question. Okay, in NEET examination, in CBSE examination, cumene processes are so many times. Okay, so and also this one is asked so many times. Now you have cumene with O2, you have this. You will have this one, okay? You will have this kind of stuff. This is C, this is H, this is CH3, this is CH3. Now this will be converted to OOH, okay? This will be converted to OOH, right? Okay, after converting to OOH, now there will be, after hydrolysis, this is phenol and this is going to be acetone, okay? Phenol and acetone, right? Okay, next the byproduct is also very important. Byproduct is also very important, that which byproduct is formed here, acetone is formed here. Next is, for benzene sulfonic acid, firstly react it with NaOH, then fuse it with NaOH, you will have sodium phenoxide. After that, do the acidic hydrolysis, then you will get the phenol here, right? Third is phenol from benzene disonium chloride. Now, how do you have phenol from benzene disonium chloride? Okay, bacha, how you have that? Okay, that is benzene disonium chloride. This is from the diazotization, that is NaNO2 at 0 to 5 degrees Celsius. Right? Okay, here H2O warm, you will get the phenol. Pour the warm water here, you will get phenol here. Right? Okay? Yes, bacha. Everybody in the chat box. Everybody in the chat box. Yes. Okay? Okay. I think let us study Gatterman and Sandmeyer's reaction. Bacha, I have completed everything yesterday. You can go through the marathon. It's a 6-hour marathon. Okay, you will find everything, all the chapters that you are confused about. I have completed all the chapters in like half hour or 45 minutes. Okay, you can go through the chapter that you are confused about. Okay, yes, okay, bacha, perfect. Now, the combined influence. Okay, so you have this 3-methylphenol. You know that this OH is ortho-para directing. This is the ortho position, this is the para position. But now this ortho position is having steric hindrance effect here. That is where NO2 will not attach here, and it will attach on this ortho position and this para position. So this is going to be 3-methyl-4,6-dinitrophenol. Okay, yes. Okay, okay, yes, I'm a good singer. Yes, now my voice is so rough right now. Okay, yes. Now, next question is Cole's reaction. You convert phenol to salicylic acid by adding NaOH. You have sodium phenoxide. Then add CO2 in acidic conditions. You will have salicylic acid. With Reimer-Taimer reaction, you will have salicylic aldehyde. With Reimer-Taimer reaction, you add chloroform and NaOH, you will have salicylic aldehyde. And if in Reimer-Taimer reaction, you add CCl4 and then NaOH, you will get salicylic acid. Yes? Okay? Perfect? Perfect. Perfect. Now, next is 2019 question, that is phenol to anisole, ethanol to propane to whole. Then these two reactions here. Okay, let us see this. First is conversion of phenol to anisole. Very easy. How do you convert it? CH3Cl, AlCl3, Friedel-Crafts reaction, and you will have anisole here. Rest, we have also done this in our organic conversions. Yes, everyone. Who has not seen my another video, another live session that I took this Tuesday for 30 most important organic conversions, please go through that. I'll provide you the link in the comment section. Please go through that because that is also very important for your CBSE board exams. Okay, now next thing is ethanol can be converted to propane to all through the following. You have ethanol. You have to convert this into propane to all. We have also done this conversion. Yes, we have done this conversion in organic chemistry. Organic chemistry top most 30 conversions. We have done this conversion. What will you do? If you want to add some carbon, no? just react this with Grignard reagent. And when we talk about Grignard reagent, have a carbonyl group there. Okay, but now this is alcohol. Then convert this into carbonyl group. I am going to oxidize this, right, with a mild oxidizing agent and convert it into aldehyde. Now you have aldehyde. Aldehyde with Grignard reagent, what it is going to do? This is your aldehyde, CH3, C double bond O, this is H, this is CH3, this is MgX, right? This is partially negative, this is partially positive. It is going to attack here, it is going to attack here. Okay, after that what is going to happen? Now you will have CH3, this is CO negative, MgX, this is positive, this is H and this is CH3. Now after adding water here, what you are going to have? This is CH3, this is C, this is CH3 and this is H and this is OH. Now you have converted this into propane to O. Yes, bacha, very simple, very easy reaction, very simple reaction. Grignard reagent is going to act this way only. Yes, bacha, everybody here understood this? Understood this, bacha? Yes, beta? Yes, perfect, perfect, perfect. Okay, aldol condensation, it is really difficult. Don't worry, I'll teach you aldol condensation at the end, okay? Yes, do remind me before ending the lecture, right? Next question was, why phenol undergo electrophilic substitution reaction more easily? Now, write mechanism for the following reaction. Okay, write the mechanism for this reaction. This is nothing but dehydration of alcohol. This is a very good dehydrating agent, awesome dehydrating agent. So it is going to dehydrate this alcohol. To dehydrate this alcohol, what it is going to do? It is going to form everyone here, it is going to form, it should be CH3, CH2, wait. Okay, the question here is wrong. It should be CH3, CH2OH. Okay, there will be dehydration from one molecule at 443 Kelvin. Temperature here is very important. Okay. Okay. Yes. Okay. So now it is going to form carbocation. Firstly, it is going to lose, and you will have the formation of carbocation. After formation of carbocation, it is going to lose H positive. The electrons are going to shift here, and you will have the formation of alkene here. Yes. Okay. Now, next question is, why phenol undergoes electrophilic substitution more easily than benzene? Why phenol undergoes electrophilic substitution more easily? Because you see, this is your phenol. This is your phenol. Okay, it has two lone pairs. The electrons are going to shift here. Electrons are going to shift here. It is going to have negative charge on ortho and para position. Because of negative charge on ortho and para position, everyone listen to this, it is going to have ortho and para negative charge. That is the reason for electrophilic substitution. It needs electrophile is electron loving. It needs negative charge. So more is the negative charge, more is the electrophilic substitution here. That is why phenol is more active towards electrophilic substitution as compared to benzene here. For this, if you want to take full marks here, just draw the structures, all the resonating structures of phenol here. Okay, draw the resonating structures of phenol here. Okay, yes, bacha. Done. Next we have, write one stereochemical difference between SN1 and SN2 reaction. So what is the difference between SN1 and SN2 reaction, everyone? What is the difference between SN1 and SN2 reaction? Yes, this is SN1 reaction. This is SN2 reaction. This is SN2 reaction. What is the difference here? SN2 reaction. SN1 reaction is two-step reaction. This is two-step reaction. This is one-step reaction. This is one-step reaction. Right? Next is two-step reaction. It is going to have carbocation. It is going to form carbocation. It is going to form transition state. That is why 3 degrees more stable, then 2 degrees, then 1 degree. Here 1 degree is more stable, then 2 degree, then 3 degree. And here we have Racemic mixture, carbocation, the nucleophile can attack from this side, can attack from this side. If it is attacking from the same side, that will be a retention product. If from the different side, that will be an inversion product. So it is going to have a racemic mixture, and this is going to have a inverted product. Okay, inverted product here. Yes, bacha. Okay, everyone. Very good. Orthopara directing group, phenol. Yes, very good. Next is racemization occurs in which one? We have just done that. In which you have carbocation formation, that is SN1 reaction, we have racemization here. Yes, okay. Next part here is what happens when anisole is treated with this one and phenol is oxidized to this. Okay, when anisole is treated with this, okay, you have the formation of everyone here. Anisole is a ortho-para directing group. Okay, this is Friedel-Crafts alkylation. Okay, here you will have two products here, that is OCH3, para product, that is CH3, and you have ortho product, that is OCH3, and this is the ortho product here, where this is going to be the major product. Okay, now next thing is phenol is oxidized with this. If phenol is oxidized, this is going to be a benzoquinone, or you can say para-benzoquinone. Okay, okay, this is going to be this one reaction. If aniline is treated with Na2CO3, also you will get the same product here, right? Next is you have tertiary alcohol is heated with Cu at 573 Kelvin, that means 300 Kelvin. Everyone here, what is going to be the answer here? Okay, copper with 1 degree Celsius give aldehyde. With 1 degree alcohol, right? Copper with 1 degree alcohol give aldehyde. With 2 degree alcohol, it gives ketone. With 3 degree alcohol, it unexpectedly gives alkene here. That is a very important thing. Okay, it is going to give us alkene here. Yes, bacha. Very good, very good, very good, very good. This is going to give us alkene here. Yes, bacha. Next we have, this is the first reaction. Okay, this is going to be the major product here because of symmetry. This is the second reaction. This is benzoquinone, and this is the third reaction where OH negative is going to liberate from this side and hydrogen is going to liberate from this side, and these electrons are going to jump here, and we will have the formation of alkenes here. Okay, we will have the formation of alkenes here. Yes, everyone, till now, any problem? Any problem till now? Any problem till now? Okay, bacha. Any problem till now? Yes, everyone. Okay. Next is CBSE 2023 question, and this is our last question of today. Okay, this is our last question of today. I know you all are having fun here. Okay, ma'am, we are having fun and all that. Please, okay, ma'am, we want to continue this. Don't worry. I am providing you one question paper that we have made specially for you, right? Okay, I am providing you that question paper, and with solutions, solve that question paper yourself. That is your task. Okay, bacha? Everyone in the comment section, promise me that I am going to give you the link maybe after 8 or 9 o'clock. I am going to provide you the link. Okay, I am going to provide you the link today only. Okay, maybe at 10 o'clock, but maybe at 10 p.m. around. Okay, I'm going to provide you the link there, and you will go through the question paper, solve the question paper yourself, and go through the answer. If any question that you are confused about, just write it in the comment section in this video or on the Telegram channel. I'll definitely answer you. Yes, bacha, promise everybody. Yes, bacha, everybody here. Do you promise me? Melvin is saying yes, ma'am, and Gry Finder is saying yes, ma'am. Sanjana is saying yes, ma'am. Naga is saying yes, ma'am. Yes, but I will give you the link on the Telegram channel. You have to solve that yourself. Then after that, or just go through the questions there. Okay. Yes. Where would you, I will provide you the link on the Telegram channel. Okay, on the Telegram channel I'll also go live, right? I'll also provide you the link. Okay, today itself I'll provide you the link. Okay, yes bacha, perfect. At 10 p.m. 10 p.m. or 10:30 p.m. I'll provide you the link. Okay, yes, perfect, very good, very good, very good. Okay, now which isomer C5H10 gives a single monochloro compound C5H10Cl in bright sunlight? Now tell me that which isomer, this is talking about free radical mechanism. Free radical mechanism. They are talking about free radical mechanism. Which isomer C5H10 gives a single monochloro compound, that is this, in bright sunlight? In bright sunlight, which compound give this? Right? They are talking about this one. Okay, this means CnH2n. CnH2n, either it can be alkene or it can be cycloalkane. Or it can be cycloalkane. Alkene cannot provide us monochloro compound, right? That means this is not possible. That means it is going to be cyclopentane. That means the answer here will be this one. Answer here will be this cyclopentane is going to provide a single monochlorinated compound in presence of free radical mechanism, or we can say heat, right? Or sunlight. Yes, bacha. Yes, I'll do the aldol condensation. Yeah. I remember aldol condensation. Yes. Okay, I'll give you one trick of aldol condensation. You will be able to solve every question of aldol condensation. Arrange the following compounds in increasing order of reactivity towards SN2. Okay. Here we do not have the compounds. Okay, these are the compounds. Okay, let us see. Let us see the reactivity. Okay, let us see the reactivity here. Okay, let us see the reactivity. First is 2-bromo, 2-methyl-butane. 1, 2, 3, 4. 2-bromo, and this is 2-methyl. Okay, this is CH3. This is also CH3. This is CH2. This is CH2, and this is this. Okay, this is a 3 degree alkyl halide, right? Okay, and in SN2 mechanism, that is transition state based, 1 degree is more reactive, then 2 degree, then 3 degree. Okay, yes, this is for SN2 mechanism, right? Okay, now next is 2-bromopentane. 1, 2, 3, 4, 5. 2-bromopentane, that means it is a 2 degree, right? Then 1-bromopentane, 1, 2, 3, 4, 5. 1-bromo means it is 1 degree halide. So obviously this is going to be our maximum rate, then this, then this. Why so? Because in SN2 mechanism you have transition state, and due to steric hindrance the order is 1 degree, then 2 degree, then 3 degree. For carbocation, that is SN1 mechanism, the order is 3 degree, then 2 degree, then 1 degree. Okay, yes. Now next question here is, why para-dichlorobenzene has higher melting point than those of ortho and meta? This is also a sample paper question. Okay, now they are talking about this one. Okay, they are talking about this one. They are talking about this one, right? This is having maximum melting or boiling point because of symmetry here, because of symmetrical arrangement. Then after that you will have ortho here, right? Because of why ortho, everyone? Anyone can answer me this? Why ortho? Because of dipole-dipole interactions. Dipole-dipole interactions are more strong here. Okay, these dipole-dipole interactions are more strong. Then you have meta. Then you have meta, where dipole-dipole interactions are there, but they are weak as compared to ortho, right? Okay, very good, very good, due to the symmetrical crystal lattice. Next is identify A, B in the following. So now you need to identify this. How do you identify this? Remember this reaction. You have Rx in presence of Mg and ether. It is going to form RMgX, that is Grignard reagent. Grignard reagent on reaction with water. Grignard reagent is so reactive towards water or moisture that it is going to get converted into hydrocarbons, that is RH. Okay, it is going to get converted to RH. Yes, everyone, understood this? So here we are going to have this, that is, this is going to, A product is going to be the Grignard reagent, that is MgX here, and B is going to be the hydrocarbon, that is cyclobutane. Okay, this is going to be the hydrocarbon here. So everyone understood this? Any problem here? Any problem here? Yes. Now the last part here, one student requested, okay, but by the way, I have completed that in the marathon, okay, just because of your request I am doing that. If you have any other problem, any other concept that you want to clear, okay, just go through the marathon, okay, just go through the marathon, just 6.5 hour marathon. Go see that in the 3x, 2x speed, you will be able to, revise everything there, right? Okay, now this is aldol condensation. For aldol condensation, the simple trick is, very simple trick that we have, join carbonyl of one molecule with double bond to alpha carbon of other molecule. This is what we are going to have here. Yes. Now what does this mean, ma'am? Now what does this mean? Ma'am, we want the example here. Right? Okay. For example, I have CH3, C double bond OH, and this is CH3, C double bond OH. Okay. For more detail, you can go through the marathon, because I have taken around 10 to 15 minutes on this one. Right? Okay? Yes. Okay? Mechanism to be learnt in alcohol chapter. All the naming reactions. Mechanisms, Rametemer reaction, Cole's electrolysis, all these, Gabriel phthalimide, then you have Hoffman bromamide, all these reactions, SN1, SN2 mechanism, right? All these reactions. Now you have this one. This is the what I told you. Take carbonyl carbon of one carbon and alpha carbon of other one, and join these two together. Okay, this is CH3, this is CH3, this is carbon. This is a carbonyl carbon. Join this with the double bond to the alpha carbon here. This is the alpha carbon. Okay, then you are going to add here. What else we have? This one hydrogen we have, right? That's it. Here what else we have? This carbon is connected to one C double bond OH. Okay, now how many valencies it is left with? It is just left with one valency, so add here CH. Okay, that's it. Now easy, perfect, easy one. That's it. Now we know the answer. Yes. Okay. Yes, bacha. Yes. I am going to. I am going to be live tomorrow. Don't worry. I'll be live tomorrow. Yes, I guess on 3 p.m. 3 p.m. is the schedule, right? Wait, just let me check what is the schedule. Let me go through it. Wait. Let me go through it. Wait. Monday we have 3 p.m. Okay, we have class at 3 p.m. tomorrow, right? Where I am going to cover top 50 assertion reasoning case-based questions where you usually get stuck, and then we are going to cover some short questions. Okay? Yes, bacha, understood this concept? Any problem here? Any problem till now? Yes, bacha, understood this? Okay? Yes. Uploaded. This is Cosmos. Cosmos Pen is asking me for the 100th time. Ma'am, will PDF be provided? Yes, PDF will be provided to you. Don't worry, that will be provided to you. You got your PDF of yesterday's class on the comment section only. Okay, on the comment section of yesterday's marathon, you will see your PDF link there. Okay, and also in this link of this in the description, and as well as on the comment, you will get your PDF link, and as well as on the Telegram channel, right? Okay, yes, Okay, perfect. Okay then, bacha, bye-bye, all the very best. I'm going to send you the question paper by 10 or 10:30 p.m. today itself. Okay, then solve that question paper yourself and go through the solutions. If you get any problem in any question, we will carry the doubts by tomorrow. Okay, I will go live at 3 p.m. tomorrow. Yes, everyone? Okay. Yes, bacha. Yes, bacha, definitely I know Tamil. I don't know Tamil language, but yeah, I try to learn it. Yeah, I'm not very fluent in it. Yes, okay, okay, perfect. Okay then, bacha, bye bye. All the very best. See you all tomorrow, 3 p.m. Right, live. 3 p.m. live, very important for assertion reasoning, for case-based questions, and for short questions, and for your doubts as well. Okay, bacha? Yes, perfect. Okay then, bye-bye, take care. Beta, cross-aldol condensation is same as that. If you have any doubt even now, just go through the marathon. There I have discussed that in detail. Yeah? Okay. Okay, Naga? Okay then, bye-bye, take care, have a great day.